this is the y, right?
No, that's
this is the x. Okay, so this is the y. Now on the x-axis, eventually, like down here, this is gonna go past. Okay,
It's only gonna hit the x-axis.
so you don't
right
include.
Because there is no more x on down here. This is it. This is one line. There's no more x. There's no more lines this way going down.
Yeah, so it's not out any farther past.
Right. -1 and 4.
It should not be a problem.
Okay, now that would be the x. Now the y.
No, we don't have to find the y.
Alright, let me change gears and talk to you guys for something real quick. If we're gonna use the online graphing calculator, which is fine, you're still gonna need some kind of scientific calculator. And please don't see your phone, okay? Because the number one way to get the wrong answer on everything is to try to do complicated math on your phone. Okay? So I really recommend you guys get some kind of scientific calculator if you don't have one. And preferably if you can get one that has the side scrolling displays where it's got the left and right buttons, because then that lets you see what you typed in. So this one is the TI-30X2S. Like Walmart and Target should have loads of these. The TI-34 Multiview is also a good one. But
Can you just use a standard TI-30?
Yeah, what you're looking for is you're looking for a button that says log on it, L-O-G.
Okay.
Okay, if the calculator has a button that says log on it, then, or LN.
So what if we have the log but no arrows?
That's okay. Yeah. That's not my first choice, but I don't love those. But if you already have one, you can use it. So. Just so you know, you will need some kind of scientific calculator. You can do complicated stuff on.
But we're gonna drop down. We're gonna have to do ranges anyway.
Yeah, we might as well.
So what do you think the range is?
All right, so let's talk about this one. Find the domain and the range. I didn't write that on here. But you guys did it anyway. Find the domain and range of these graphs. Here's our first graph. Okay, now remember, domain means you're kind of boxing in the function on the x-axis. So can I box in this function on the x-axis?
Yes.
Yes.
-1 and 4.
So if I draw a box from -1 to 4, does that box in the function?
Oh, no.
See why not? Function goes outside the box, right?
Could be negative.
People get really distracted by where it crosses the x-axis. Domain has nothing to do with crossing the axis. Domain has everything to do with boxing it in. Okay? What if I move my box? What if I move my box out here? Would that work?
I'll wait for this view of the graph. Let me know if it's
Okay. It seems to work now. My box does. But what if I zoomed out and made my graph bigger? It would get wider, right? And it would go outside the box.
So we want to cross the x-axis again.
We don't care about crossing the x-axis. We care about boxing it in on the x-axis. Okay? So we want like a left box and a right box that would hold the entire graph. Does that make sense? So my left box and my right box work now, but if I zoomed it out, I would have to keep moving them out, and I would never know where to stop. Okay? So really, we can't box this thing in on the x-axis. I mean, just in the left and right direction. Okay? So what is my domain then? Okay? So my domain is infinite. I can have anywhere on the x-axis this graph would have a point. Okay? So how do I say that?
Parentheses, -infinity, comma, infinity.
Negative infinity to positive infinity. Okay? And use parentheses with those always. Okay? Now just to give you guys a tip, anytime the function has arrows, you've got one arrow on the left side and one arrow on the right side. If you've got two arrows going in opposite directions, the domain is always going to be negative infinity to positive infinity. Because it's always going to be going left and right forever. Okay? Yes. It's always going to be going in opposite directions, left and right.
So you mean when those arrows cross the main part of the graph? Like you have one in the negative and one in the positive.
No, I just mean they're going, the
It's
graph
just
is
like
going
on
left and right.
on this example
It's
here.
like this one where the arrows are going in opposite directions.
And they keep going.
The arrows
So you
indicate
know
that it
that no
doesn't
matter
stop.
what, at some point it's
It
all
doesn't
gonna.
stop. Yeah, the arrows will tell you it's going to keep going forever. Okay? So it's going to keep going down, and it's also going to keep going out. It's getting wider. Now, why do I have to assume it keeps getting wider? This is just a thinking question. Why do I have to assume it keeps getting wider? What would be a problem? What would be wrong with assuming it doesn't get wider?
Because it stops at that point. The one part of the line goes.
If it doesn't get wider, you're going to be able to box it in at some point.
If it doesn't get wider, it would have to be vertical, right? And we can't have vertical. If it doesn't get wider, it would have to just be straight up and down, which is a vertical line, and that's not a function. Can't have a vertical line. Okay? So that's why we have to assume it keeps getting wider, and it does keep getting wider. Don't worry too much about that. Don't stay up at night worrying about why it's getting wider. That's just a thinking question. Okay, here's our second graph. You guys want to take a look at this one for a second?
What was the range would be negative infinity
Oh,
and
we
2?
didn't do the range. Right. What's our range here? Okay, so I can box this thing in at the top at positive 3 on the y-axis. You know, it doesn't go above there. Keeps going down forever, so my lower end is negative infinity. Then I go up to positive 3, parentheses, bracket around the 3. Okay, if it looks like it hits 3, you can assume that it hits 3. Okay? Okay, now I see a lot of people that understand what this is and they write it backwards. Do not write it backwards. Okay, negative infinity always needs to be on the left because it's always the lowest. Question? Okay, now let's look at the second one. Okay, now let me tell you guys, these points where it crosses the axis here, you do not care about this point. What point do we care about? This one. We care about this point. Okay, you only care about the endpoints and then you care about what the arrows are doing.
Where is that about? Negative 2.5? 4? Or is that supposed to be on the 2?
She's not doing half.
So it should be on the 2, probably.
Yeah.
So x would be 1, right?
Negative.
It goes for 1 and then it goes from
Down to 1, 2, 3, 4. Yeah.
What did I say about 1 and negative 1? What did I just say about those?
I don't care about those. So would it be infinity?
Care about those?
Oh, that's right. So 4. Right?
Wow.
Oh.
Yeah, because they're going to go over. Yeah.
Yeah, it's a definite ending. It definitely ends. So.
-1. And then infinity.
So if you're not allowed to have one, is it just for x or for everything?
No, just because of where her point is.
-2.
Oh. Not, it doesn't matter where it crosses the graph, it's just where the point ends up. Or where there's an arrow.
And so the negative
Oh,
4
so. So would the range be the same thing then, -4?
Yeah. Yeah, 3 or 4.
And infinity?
Yeah, because it goes from, on the
Yeah.
x-axis, it goes from -3 over
Yeah.
the y-axis, right, can be boxed
No.
into.
So the first one would be
The first one would be -3.
What's the range going to be then?
bracket -4.
No, the domain is always
Okay,
the
yeah,
x
because it
value.
definitely ends there.
Yeah. Or on the range.
-3.
If you say x, then you're talking about domain. Domain always refers to x values. So that's okay, but that's the range of the domain. If you say -4, because -4 is the y value.
Yeah.
You want the x value, I don't know if it's -2 or -3, either one.
I would say it's 2, -2.
Yeah, it's kind of in between them. I think most people were saying 3, so we'll call it 3 here.
So negatives change.
Well, I already drew it on the daggone 2.
Infinity?
Yeah. That messes up my whole darn thing.
Alright guys, what's the domain here? Can I box this in left or right? I can box it on the left, right? Right here. I can't box it on the right because it's going to the right. So what's my domain? If you guys call it -2, that's fine. -2 or -3 is kind of, we call it -3 up here. So positive infinity.
And the range.
And the range. Can I box this thing up or down?
Down.
I can box it down here. Okay. Now it looks like it's kind of maybe not going to go any higher here, but if it's going up and out, I can assume it's going to keep going up no matter how slowly it would go up. So I don't want to box this thing on top.
So -4 to infinity.
-4 up to positive infinity. Okay, now if they want you to find the domain and the range, they're going to need to give you a graph or a table or a set of points. If they only give you an equation, then they're only going to ask for the domain. Okay, you're not going to ask for the range. To find the range is a little, if you just have an equation, you would need to see the graph. So if you just have an equation, they're only going to ask for the domain. Okay? Now, when you're trying to find the domain of an equation, there are two things we're concerned about. Okay? The first thing we're concerned about is that we can't have 0 in the denominator of a fraction. have 0 in the denominator for fractions. You can't divide by 0. If you don't believe me, type in 2 divided by 0 in the calculator. See what it says. Okay, the second thing we are concerned about is we can't take the square roots of a negative number. For now, we cannot take the square root of a negative number. You guys are going to be upset later on when I tell you that we actually can take the square root. But not for now.
That'd be nice, but
Yes.
yeah.
So if there's something you can't do and you want to do it anyway, then math means you just make up something that lets you do it. Okay, but for now, we can't take the square root of a negative number. Okay, so you need to be concerned about those two things. And if neither of those things is happening in the function, like you don't have any fractions to worry about, and you don't have any square roots to worry about, then otherwise you don't have a problem. So otherwise the domain is negative infinity, positive infinity. Okay, those are the only two things you need to worry about. Anything else, the domain would be negative infinity, positive infinity.
Wow, that's kind of simple.
Yeah, kind of simple. Although,
Here I was expecting you to actually have us work the formula out and then get that.
what do you mean formula?
If it's an equation, work the equation out.
Oh, you want equations? Okay, we want equations. Okay, so let's find the domain. Let's do 4 examples here. Let's do y equals 2x plus 1. Y equals 4x squared plus 2x plus 5. Okay, let's do y equals 3 plus 4 over x plus 1.
Are we doing this?
No, I'm going to do these and then I have some other good ones for you guys. Okay? And let's do y equals the square root of x plus 1. Okay, so what's the difference between the first two and the second two?
First fractions and square roots of the second two.
Second two have stuff we need to worry about. I've got a fraction here. I've got a square root here. That's stuff we need to worry about. First two don't have those. So if the first two don't have anything that we need to worry about, then what is the domain?
Okay.
Negative infinity.
Negative infinity to infinity. Okay, so no square roots, no fractions. Domain is automatically negative infinity to infinity. Because there's nothing that I need to worry about in those functions. Okay, and if you think about it, those two, I can really plug in any x value. I'm never going to have a problem. Like, I can always multiply by 2. Okay, I can always add 1. I can always square any number. Okay, if these things that we are worried about is the x plus 1 in the denominator and the x plus 1 under the square root that we are worried about. Okay? Now the 3 plus in front and the 4 in the numerator, we don't care about that. You only care about the denominator here. Anything else that would have been going on here, like if they had a plus 4 tagged on at the end or something, or a number in front, you only care about under the square root. We only care about denominators, we only care about underneath square roots. Okay, so for this one, let's look at number 3 first. I want the denominator not equal to 0. Okay? So what I need to figure out is what number would make it equal to 0. Negative 1 would make it equal to 0, right? So if you can't figure that out, what you can do is take the denominator and set it equal to 0 and solve for x. So I want to say what would make that 0. Now this one's easy enough to figure out. Sometimes they're not as obvious. X equals negative 1 would make that 0. So x equals negative 1 is what we can't have.
So how would we write that out in the interval?
Okay, that's a good question. How would we write that out in an interval? So if x is not equal to negative 1, let me write this down here. So here my domain if I just wrote it out in words, I would say x could be anything but negative 1. Okay? So I would want anything less than negative 1, anything greater than negative 1, just not equal to negative 1 itself. Okay, now you're actually going to need 2 intervals. You're going to need one interval that tells me everything less than negative 1, and you're going to need one interval that tells me x is greater than anything greater than negative 1.
So negative infinity to negative 2.
Okay, I want anything less than negative 1. How would you say anything less than negative 1?
Negative 2.
Not negative 2.
Negative 1.
What about negative 1.5? What about negative 1.00001?
Alright, so anything negative 1.1.
Now the parentheses here tells me I'm just going to get as close as I want to negative 1, but not actually hit it. Okay? So I can go up to like negative 1.000000001, and that would be okay. Okay, that the parentheses just tells me I'm not going to hit negative 1 itself.
You can go through it. You just can't hit it.
Why would it be negative infinity? Because you can't go any less than that, than negative 1.
No, you can go less than negative 1. You just can't have negative 1 itself. So anything that's not negative 1 would be okay. Like negative 2 is okay. This is not equal to negative 1. Anything but negative 1 itself is okay.
So you can have a negative number in the denominator, you just can't have 0.
Can't have 0. Anything but 0 is okay. Positive, negative, whatever.
Okay.
Fraction, whole number, decimal, anything, just not 0. Okay, how do I say anything greater than negative 1? Okay? So this is my domain. This interval is part of my domain, and this interval. I've got 2 intervals together that make up my domain. Okay? Now how do I say 2 intervals together?
Compound inequality.
Not compound inequality. This is probably a symbol you guys haven't seen before, so just roll with it. It's a giant U. Okay? That's called a union symbol. The union symbol means or. Okay? So this is really like saying this interval or this interval is okay. Okay, so that symbol means or. When you see that symbol, it's not a U on the keyboard, it's like a different U. If you need to type that symbol, they'll show it to you on the left. So if you see that symbol pop up, you might think, oh, I may need to use that.
Yeah, you have to hit the more button and then the little bubble
Well,
pops up.
it should be there if you need it.
So there's no combination of the two
The
of
opposite of
those.
union, if you flip it upside down, it's called intersection. It means and, but you won't see that in this class. You only see the union. Okay, so that's my domain for number 3. Okay, so that's what you want to do for the fraction.
You said that you think means or.
It means or, yes. Okay, now for the square root, what you want is you want the stuff under the square root to be positive. Okay? Now what does it mean to say something's positive?
It's above 0.
It's above 0. Now is square root of 0 itself okay?
No.
Try it on the calculator. You guys got a calculator. Square root of 0 is okay. If you type square root of 0 on the calculator, the answer is 0. Because technically 0 squared is equal to 0. It's kind of trivial, but technically it's true. Okay, so square root of 0 is okay. So to say something's positive, really 0 is included here. I want to say greater than or equal to 0. Okay? So to figure out what would make that true, I want to take the stuff under my square root, and I want to set it greater than or equal to 0.
Okay, but how can 0 be considered positive?
It's not negative.
Yeah, but
It's
not
really
positive.
neither. But, well, not. Well, really me saying, we're doing. The camera's like on my stomach right here. It's positive's not really the right word there. It's really positive or 0.
It's really the function there with the square root.
It's really that you don't want it to be negative, not so much that you want it to be positive. Okay, now I want to, yes, question?
Are we gonna have a break yet or not?
Yeah, we're going to have a break in a second. Let's let me get through this. Yeah, I know, I have to go to the bathroom too.
I know.
1 second. Let's just do this problem. I want to treat this like an equation and just rearrange it to get the x by itself. Okay? So subtract 1, subtract 1. I get x is greater than or equal to negative 1. Okay? So x is greater than or equal to negative 1 would be my domain. I just need to write that as an interval.
So there's the line, then. Oh,
And greater than or equal to negative 1 would be negative 1 and up.
Then you put the bracket.
Bracket.
Yeah.
Parentheses. Okay, now I got a couple for you guys to practice on. We'll do that after the break. It's 12:14. Let's come back at 12:30 again. And then we'll practice. Jonathan, can you pause this or so we don't have 15 minutes of dead air? Okay, just show me how to pause it so we can pause.
Actually, I just have to stop.